Okay, folks, in this video I'm continuing my module on quadratic equations and quadratic functions. And so in the last video we discussed how easy it is to graph something in standard form. It's just the case is you're not always given quadratic functions already in standard form. And so it is convenient to learn a way to rewrite from typical forms to or common forms into standard form so that we can graph things very, very easily or identify the vertex or vertices very, very easily. And so we're going to use a process that we used in algebra, most likely, called completing the square. Okay, and so completing the square, what I want to point out is this. First of all, recall that we say the standard form of the equation of a parabola is this. We say a times the quantity x minus h quantity squared plus k. The important thing here is this, however. We say we need this quantity x minus h squared, which when one considers it, is just a binomial times itself. And if we were to actually multiply this out, FOIL it, we'd get x squared minus hx minus hx, so minus 2hx, and then we'd say plus h squared. And so I guess what I want to point out is this. If we're often given things that look like this, ax squared plus bx plus c, we could actually factor this down into something that had a binomial squared, which is this thing that we need to put into our standard form right here. Okay, but some things would have to be true about b and c in the first place, and that would just necessarily have to be this. But essentially, we'd say this last term here, h squared, which is, they say this h times this h, is a perfect square, this last number, and it is a perfect square of half of the middle term. So what I want to point out here is this. The middle term is like negative 2h right now. We'll kind of show some examples of this. But if I were to divide that in half of 2h is just h, and then that equals the last term here times itself. Like half of 2h is h, of course, and then we say h is this last term right here, the one that we're taking and squaring it. But if we ever have a polynomial expression that is of this form, then we can factor down into what we call a perfect square binomial, which is just like something like this. So real quick, I'll throw a couple of examples at you. This would be something like x squared minus 6x plus 9. I know this is a perfect square binomial and can be factored down into x minus 3 squared, and let me tell you why. The reason why is because of this. If you take the middle term and chop it in half, that is, negative 6 over 2, you get negative 3. And negative 3 squared is, dun, da, 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 this guy right here. Okay. So what we're looking for is anything that is a trinomial of this form, ax squared plus bx plus c, where a is 1 in this instance. But we say half the middle term squared equals the last term, then it can be factored down into something like this, which is what we desire. We want to have something that is a perfect square binomial because that looks like standard form. It looks very standard with our h value there. Another example might be, x squared plus 4x plus 4. We say half of the middle term is 2, and 2 squared is 4. Then this must factor down into a perfect square binomial. And, the next question I usually get is this. What number should I put here? Well, it was just half of that middle term that we squared to get this 4 in the first place. So we just put that in there. So half of this middle term is positive 2. Look at the example I gave. Right here we say half of negative 6 is negative 3, and negative 3 squared is 9, so this must factor down into a perfect square binomial, but half the middle term was negative 3, and that is what we'll put right here. In general, we could say x squared plus I don't know, like 12x plus c. What I want c to be in order for this to be a perfect square binomial. Well, first of all, I'd say, well, what's half the middle term? 6, and we'll square it. 36. So first of all, I'd want this to be 36, and if it was 36 and I knew it factored now, what would go in here? And I'd say, well, half the middle term, so plus 6. So that being said, if that's our goal, is to get things to be rewritten into standard form, then we're going to have to cause these things to be able to be factored down into perfect square binomials. And if that is the case, then we need to rewrite our things as trinomials where the last term here, the last term, right here, is always half of the middle term squared. Okay? So let's go ahead and start by taking a look at example A here. We say f of x equals x squared plus 6x plus 3. I'm going to start by rewriting this as y equals x squared plus 6x plus 3. Now our intent is to rewrite this in a standard form, which means kind of like up over here on the right, we say a times the quantity x minus h squared plus k, which means we need to factor this expression, this trinomial, down into something that is a perfect square binomial. And as we've just discussed, this will only happen if half of the middle term here, which is 3, if I square that, I get the last term. And what do you know? If I take half of 6, which is 3, and square it, I get 9. I don't get this 3 right here. So here's going to be the way we kind of deal with this in general, and this is a way I'll kind of explain it to us. But when you complete the square, we will always start by this. Let's just go ahead and kick the loose term over here to the other side. And I know it's not a necessity. It's not, as a matter of fact. But for now, I'd like to show you guys to do it this way. So we say y minus 3 on the left, and this is equal to x squared plus 6x plus, and I'm going to write blank. So now the question becomes this. What would I want to have right here in this last spot so that when I factor the right side, it becomes a perfect square binomial? And the answer to that is always, again, half the middle term squared. So we say half of 6, which is 3. 3 squared is 9. I'm going to add 9 to the right-hand side. Recall from any algebra class you've ever taken that if you add something to the right-hand side of an equation, you must also add it to the left. So typically when we do these problems, when you wrote plus blank on the right, it is good practice to write plus blank on the left and just add the same number at the same time. So now here's what we end up with. On the right, x squared plus 6x plus 9, which is wonderful. And on the left, after combining like terms, we get y plus 6. So the right side, let's go ahead and factor it. And not only does it factor, oh my goodness, it factors wonderfully down into x plus, now hold on, I know it's a plus because we're going to fill this blank here in with half the middle term, and the middle term was positive, but half of 6 is 3. So we just rewrote the right side so that it would become something that does factor down into something that looks like this. Now the left side, which is still y plus 6, let's go ahead now and kick that loose term back over to this side. And what we end up with is y equals x plus 3 squared minus 6. Okay. So now if you've read the instructions up here, it says use the process of completing the square to A, write down the following equations into standard form, which we've just done. B, identify the vertex, and if you recall from the last video, the vertex is always at hk if it is in standard form. So the vertex of this, of course, would be at h is negative 3, as a matter of fact, it's lying, and k is negative 6. And then we'd sketch a graph of this parabola. Okay, well, hey, it'll only take me a second here. We say left 3, 1, 2, 3, down 6, 3, 4, 5, 6. So here's our vertex, and it has its axis of symmetry running through it at x equals negative 3, that vertical line. We say the a value is 1. So if the a value is 1, we'll just go up 1, right 1 from here to get to our next point on the parabola. So we'd also proceed up 1, left 1 to get to the next point on the parabola. Okay. So now this is the instance that we work through if a is 1, that is if the a value is 1. If a is 1, if you're taking notes, we have to do an example where a is not 1. So we're going to say a not 1. This is our a not 1 example. Okay, so let's go ahead and start with what we've been given, which is y equals 2x squared plus 8x plus 7. We want to rewrite this into standard form. We're going to have to make the right side a perfect square binomial. So again, hey, we're going to start the same way we did on the left there. We're going to go ahead and start by booting this loose term to the other side. This is kind of a good first move every time. But we'd get this on the left, y minus 7. On the right we have this, 2x squared plus 8x. Now in the last instance I said plus blank. What I would like to do this time is, and the plus blank's not a bad thing, but point this out. That half the middle term squared to get the last term thing only works if this leading coefficient is 1. So we need to make this leading coefficient into a 1, and our tactic to do so is going to be this. On the left we still have y minus 7. I'll write plus something here. But on the right side, we're going to factor out the leading coefficient, in this case 2. So we take the 2 out front, and we get left with this on the inside. 1x squared plus 4x plus 4x. Let me make clear that this is a 4x plus blank end parenthesis. So now I can answer this question, because now my leading coefficient in here is 1 on the inside. So I can say, well, half the middle term, 2 squared is 4. We'll go ahead and put a 4 in this last spot. So again, whatever we add to the right, we got to add it to the left. But in this instance, I want to point out one real quick thing. If I were to redistribute this 2, we didn't technically just add 4 to the right side, we added 2 times 4 to the right side. So on the left side here, we'll write 2 times what we put in there. And so basically, I just, this leading coefficient we factored out, I always put that here and then take it times whatever we decided to add on the inside. But what this yields is this. On the left, we have y minus 7 plus 8. On the right side, we have 2, and this factors down into our perfect square binomial of x plus 2, because half the middle term in this instance was 2. And then now we can just combine these like terms, which come out to be a positive 1. So y plus 1 is 2, quantity x plus 2, quant squared. And then subtract that 1 back over to the right side. But what you'll see, dun, 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 is y equals 2 times x plus 2 quantity squared minus 1. Here's our standard form equation. We have the vertex at -2, -1. So vertex at -2, -1. And since we have the a value, we could totally sketch this. So cheers.